film about marine energy. In Scotland we used to produce a lot of power from coal and then from oil and gas and from paraffin shale and from all sorts of other fossil fuels. But these fossil fuels are now running out, and we have to try and find a new source of energy. And we're going to talk in this film about how we get power from the ocean, how we get wave and tidal current power and turn it into electricity.
This is the Pentland Firth. We're right at the top of Scotland. To the west is the Atlantic Ocean, to the east is the North Sea. And these two huge bodies of water are forcing their way together through the Pentland Firth twice a day, causing enormous tides to run. Now, how much water is going through there? There is 3 million tonnes a second travelling through that firth at the highest tide. That's the equivalent of 1,000 Olympic swimming pools filling up every second. And the speed that it goes at, well, it goes at 30 kilometres an hour, and that's almost as fast as Usain Bolt, the sprinter. So that's the force that's in the water here. It's no wonder that it's caused marine energy to be a tough thing to do. It's no wonder it's caused problems for shipping. And it's no wonder that this is the only piece of water around the British Isles no one has yet been able to swim.
Andrea Gellan from Dunfermline is a super mum. She swam the 22 miles of the English Channel, but last year failed to make it 8 miles across the Pentland Firth. Her consolation, no one else did either.
Just amazing. I've never swum in anything like that. At one minute I was swimming through water that was really, really choppy, and the next minute it would be flat calm, and the next minute it would be rolling waves, 2-metre swells. You know, it was different all the time. It was constantly changing. I really felt at some points I was swimming through a whirlpool.
Willie Simpson's dad Jimmy owns the island of Stroma in the swirling midst of the Pentland Firth. It's depopulated now. Those powerful tides are just too scary for most folk to tackle.
Well, the tides is really quite, to describe the tide is really, it was a very, very difficult place to navigate in the olden days. Nowadays with satellite navigation everybody knows exactly where they are on the globe. But in olden days when ships were using compasses and things, the towed behind them would be what we would call a log line, which is basically like a measuring wheel. So they would be going 7 knots in this direction, and the tides would be going 7 knots in that direction. And if there was fog, they thought they had travelled X amount of miles, because that's measuring wheel, but they were actually going nowhere. So they would turn then, as I say, it'll go north, south, wherever, and crash, bang, wallop, land on the rocks, because they'd actually travelled nowhere. So I mean, tides really, when you see ships going against the tide, it's exactly like being on a treadmill. They're walking, they're travelling along, but going nowhere.
And here's why. Those fast tides round Stroma rip across an uneven seabed full of deep holes, channels and tunnels. And this is not Mount Everest, it's the seabed round Stroma. Those blank holes show where the island is. These seabed maps have just been produced 40 years after the first moon landing. There are plenty of tidal sites round Scotland, the best are shown in yellow. But the sea is powerful and still unknown. And what precisely is a wave?
Ocean waves are generated by the wind blowing across the sea, and as the wind blows across the sea, it generates small ripples on the surface of the water, and then those ripples build up into larger and larger waves. And if you're out in the middle of the deep ocean in a boat on the sea, you'll see waves coming at you from all different directions. You'll see large waves and small waves superimposed on top of one another, coming from all directions. And this gives us a very lumpy kind of sea surface that we would say was choppy or mixed up, that you can see in the pictures from the wave tank, and we can simulate that. As you come into nearer shore, the waves start to line up with the coastline because of refraction of the waves. As the waves feel water getting shallower, it makes the waves line up into a preferred direction. And in those circumstances, we get what we call a long-crested sea.
But how does a device get energy from waves, short and choppy or long and crested? There are 3 types of wave energy: sway, heave and surge. Here are the heaving paddles of Wavestar in Denmark and the surging oyster device off Orkney. Still not clear? Take it away, Edinburgh University Science Department. That's wave power. Tidal's different. It doesn't want heaving or surging seas. Tidal devices harness the powerful, even flow of tides, a bit like wind turbines, but slower.
If we have a small turbine blade, or a relatively small size of a turbine blade, if we just move it around like this, so I'm hardly moving my hand here, but it's moving quite fast. So if we take this as our example for the wind turbine, when you've seen those, the blades are probably moving quite fast and you wouldn't really want to get in the way of those. So just to change that, the length of that, to something that would probably be similar to a tidal turbine, if I just get this going. So I'm moving my hand exactly the same as I was with the wind turbine or with the smaller length. And you can see that for exactly the same amount of energy that I'm putting in, the actual turbine blade is moving a lot slower. So when you have that in the sea, don't worry that seals and fish and everything else are going to get caught up in this, because it's moving an awful lot slower than what you see with a wind turbine.
But conservationists are worried about seals, worried enough to have the world's biggest seal monitoring project in Strangford Lough near Belfast, where SeaGen is proving it produces tidal energy without damaging wildlife. And don't worry, those transponders come off when the seal sheds its fur every year.
This is an amazing sight behind us, and one we'd rarely see here in Strangford Lough, because SeaGen, which came here in 2008, has its turbines raised for maintenance, and that lets you see the extraordinary phenomenon that's managing to capture tidal energy here in the Straits. Part of that has involved an engineer standing on that tower behind me on SeaGen and looking on the surface to see if seals are approaching, and if they are, they have to hit a button to stop the turbines.
That's not all. Onshore, this marine scientist, Andy, watches underwater seal movements using sonar.
If somebody says, okay, I've seen a common seal diving at 80 metres, can you see anything? Because obviously this is seeing things under the water. You can't do that with binoculars. It's sort of all subacoustic stuff. So if they say, so see something diving, I can sort of train the sonar on that area. From experience, I can say, well, that was a seal, you know, it looks very like it. You just lean across and press one button on the turbine panel here, and that will shut the turbine down in 3 seconds.
So you don't even need to get your feet wet?
No, it's all remote, all remote.
Just as well, even big heavy monitoring devices fixed underwater can get swept away.
We deployed a couple of them on the seabed, and unfortunately we lost them. They were really weighted down on the seabed, and we went back a couple of days later and no sign of them. So you know, it gives you some idea of what goes on there when the tide is running in the narrows there. There must be cobbles, stones, rocks rolling around the bottom and sediment, and you know, it must be an incredibly dynamic environment, which obviously it is.
Seals are dynamic too, but 3 years of sightings show they avoid the pink dot where SeaGen stands. The dark blue blobs are seals, happiest at the loch sides, where water speeds are slower. David Irwin's a conservationist. He's happy with SeaGen here, but wonders how a SeaGen wave farm could send energy onshore without spoiling landscapes like the spectacular Antrim coast.
The problem is you've got to get the power ashore, and that's all protected landscape up there, and yet there are lots of developments proposed up there. How do we get that power ashore without having columns, pylons marching from the coast in a protected landscape? That's one of the big questions we have to answer.
10 years ago, we had models of machines in laboratories like this one, wave and tidal energy machines. And today we have real machines in the water generating electricity. And in your lifetimes, we're going to move to the situation where we have hundreds of machines generating gigawatts of energy into the grid and providing a big source of employment for people like you and generating power for the future.